हेलो स्टूडेंट्स, वेलकम टू दिस चैनल। इस वीडियो में हम इरदोव जनरल फिजिक्स की प्रॉब्लम नंबर 1.27 सॉल्व करेंगे। पहले प्रॉब्लम पढ़ते हैं। ए पार्टिकल मूव्स इन द प्लेन एक्स वाई with constant acceleration w directed along the negative y-axis. The equation of the motion of the particle has the form y is equal to ax minus bx square, where a and b are positive constants. Find the velocity of the particle at the origin of coordinates. हमको इस प्रॉब्लम में पार्टिकल की वेलोसिटी एट द ऑरिजिन मीन्स x is equal to 0 and y is equal to 0 पर निकालनी है। तो इसेंशली मोशन यहाँ पर 2 डायमेंशनल है। सो बोथ x एंड y हियर इन दिस आर फंक्शन ऑफ टाइम। y इज इक्वल टू ax माइनस bx स्क्वायर इज गिव्स द पाथ ऑफ द पार्टिकल। तो यहाँ पर हम लिख सकते हैं y इज ए फंक्शन ऑफ t इज इक्वल टू a, x इज ए फंक्शन ऑफ t माइनस b x स्क्वायर। This is the equation given in this problem. Now it is given the direction of the constant acceleration is along negative y-axis, that is d2y by dt square. This is the acceleration along y-axis. This is equal to minus w. It is given in the problem. Now differentiate again this problem. Equation 1, dy by dt is equal to a dx by dt minus 2bx dx by dt. This is the velocity along dy by dt gives the velocity along y-axis. Again differentiate problem equation 2. It gives the acceleration along y-axis. d2y by dt square is equal to a d2x by dt square. Minus 2b is a constant. So we have to differentiate x into dx by dt. x into dx by dt का differentiation होगा dx by dt का whole square plus x d2x by dt square. This is the equation number 3. From these 3 equations, one is the path of the particle, this is the velocity along y-axis, and this is the acceleration along y-axis. These 3 equations. इन 3 equations से हमें velocity at the origin estimate करना है। Now it is given d2y by dt square is equal to minus w. Acceleration along y-axis, negative y-axis is constant. So we can put d2y by dt square as a minus w. And there is no acceleration along x-axis, that is d2x by dt square is equal to 0. So in the third equation, we can put d2y by dt square as minus w, and this goes to 0, d2x by dt square, and here this is also goes to 0. So what is left? Minus w is equal to minus 2b dx by dt ka whole square, this term. So from this we can find out dx by dt is equal to square root w upon 2b. W is a constant acceleration, b is a positive constant, so this is constant. So it is dx by dt. So essentially this is the velocity along x direction. Now you see it is a constant. This is the x component of the velocity at the origin, because it remains same at all times. So at origin x is equal to 0, y is equal to 0, dx by dt, that is the x component of the velocity, is equal to under root w by 2b. Now if you see the equation number 2 here, at the origin this x goes to 0, and if we put the value of dx by dt जो कि हमने भी निकाला है, तो we can find out dy by dt. So we can get at the origin dy by dt is equal to avx. Here you can see a, this is the dx by dt is the x component of the velocity, avx. This term goes to 0. And put the value of the vx means dx by dt. So this is vy is equal to a under root w by 2b. This dx by dt and dy by dt both are obtained at the origin x is equal to 0, y is equal to 0. That is we can consider it as initial horizontal velocity, initial vertical velocity. So both velocity Vx and Vy, these two are at origin. So resultant velocity at the origin will be square root of Vx square plus Vy square, and this is the square root W by 2b 1 plus a square. This is the answer. This is the resultant velocity at the origin. Now suppose we extend this to problem. We have to calculate the a and b in terms of initial velocity. What is a and b essentially? So you can see at the origin dy by dx, this is the dy by dx slope. It is at origin is equal to dy by dt dx by dt. If we divide these two, dy by dt and dx by dt, we get a. It is a constant. So a जो है, that is the slope at the origin. So we can say it is equal to tan theta. Theta is the angle of the velocity vector with the horizontal. Now since minus w is equal to minus 2b dx by dt whole square from equation number 3rd here, so if we put from the here, we can put the value of Vx dx by dt. So we can find b. B is equal to w by 2 Vx square. So Vx is the horizontal velocity. So here we can see a is the tan theta. There's a slope at the origin, and b is equal to w by 2 u square cos square theta. Vx is equal to u cos theta. So now we see these two values a and b, and if we put these two values a and b in equation 1, we get the projectile path in terms of initial velocity. If we put a and b, we can find the projectile path here. Now we can see how the computer algebra system wxMaxima software can be used to find the derivatives of the function. Maxima software you can download from this website maxima.sourceforge.io. हमने अपने अर्लियर वीडियोज़ में मैक्सिमा सॉफ्टवेयर्स के और डिटेल भी दिए हैं, आप उसको देख सकते हैं. मैक्सिमा सॉफ्टवेयर को डाउनलोड करने पर अगर हम उसको देखते हैं तो उसका इंटरफेस इस तरह से आता है. दिस इज द इंटरफेस ऑफ द मैक्सिमा सॉफ्टवेयर. फर्स्ट 3 lines is the input commands which we give, and these 2 lines the output command which we obtain. हमको मिलता है output commands से. So input commands हमको ये 3 equations जो दी हुई हैं, इसको हम मैक्सिमा में कैसे लिखते हैं ये हम देख सकते हैं कि मैक्सिमा सॉफ्टवेयर में हम yt is a function of t colon equal to sign, because we have to define as a function axt minus bxt square like this, and diff, this is a command for differentiation of function with respect to t, and diff, it is again differentiation command, comma 2, it is the second derivative. So this is the velocity vy, and this is the acceleration d2y by dt square. If you run this command, output we will get this. You can compare this output which we had obtained earlier. This is a d2y by dt square. Here you can compare it here, and it is the same. This is, and this is dy by dt, and इस आउटपुट में हम d2 by x by dt स्क्वायर को 0 पुट कर देंगे तो हमको जो है dx by dt मिल जाएगा इस थर्ड इक्वेशन से, और dx by dt की वैल्यू सेकंड इक्वेशन पुट करके हम dy by dt निकाल लेंगे. बाकी एनालिसिस यहाँ पर दी हुई है. सो आई होप कि ये वीडियो आपको पसंद आया होगा, और थैंक यू वेरी मच.